We are going to be covering a very important and useful feature in KDB Plus called attributes. Attributes are easy to understand and can truly make your life much easier if you're dealing with a lot of data, which you mostly are when working with KDB. One of the biggest advantages of KDB is fast data retrieval. As a client, you simply run a QSQL command and you're given millions of rows of data within seconds. How does KDB do that? There are many factors that contribute to high retrieval speed, and one of them is table attributes. So what are attributes? They're simply metadata that can be applied to lists of special form. Their most common use case is being applied to tables and dictionary domains. They allow for faster lookup and are mostly used when dealing with large tables with at least 1 million rows. Using attributes with smaller datasets can actually deteriorate performance. So we would highly recommend to not do that. Just make sure that you understand when to really use them, because when they're applied in the right situation, they can be amazingly helpful. There are 4 types of attributes that you can use. Sorted, which is used for data in ascending order. Unique, which applies to, unique data. Parted, which applies to data where the same values are adjacent to each other. And finally, grouped. When applied, it creates and maintains an index. We're going to cover each of these attributes in detail now with some examples. Okay, so let's begin with the sorted attribute. So the default lookup method in Q is linear. So looking up data for, let's say, Apple symbol in a trade table that contains millions of rows can be very time consuming. However, if the data is already sorted, Q uses binary search, which speeds up the lookup process. So here's how you apply the attribute to a list. So let's define a list and we'll name it A. The way you apply sorted attribute is using this syntax, backtick S and then a hash and then your list 1, 5, 9, 10, let's say 20. So now if we print that out, you'll see that we have the attribute attached to this list. Again, this is just a metadata that tells the Q interpreter that this list is already sorted. If you tried applying this to a list that wasn't sorted, you'd get an error. So for example, 1, 3, 9, 5, 7, it would throw a S-fail error. So Q checks before applying an attribute whether it really does apply or not. Sorting the data using one of the built-in functions will add the attribute automatically. So if you were to use ascending and you're on the same list 1, 3, 9, 5, 7, we call that ascending, basically sorts the list in ascending order. It will apply the attribute automatically. There's currently no way to apply an attribute with descending order, so it only applies to ascending order. The second attribute we're going to discuss is called unique. This attribute tells KDB that the content is unique. However, unlike the sorted attribute, unique attribute keeps a mapping in the background, basically a hash table, which can lead to some overhead. So we have a unique list. So similar to sorted, same type of syntax except for backtick S, you're using backtick U. The third attribute is called parted. Parted is a very important attribute. It can be applied to data structures with integral values, such as dates, timestamps, and integers. It is especially used when storing data in a historical database on disk. If I gave you a trade table with 1 million rows and asked you to get me all the rows for Apple, where price is greater than 400, you would have to scan the table linearly, which is very time consuming. What if I told you before you start searching, Apple data is stored between rows 10 and 15? This will drastically speed up the process because now you only have to look at 6 rows. This is the whole point of parted attribute. If a table has the parted attribute on the sim column, KDB knows that the data is arranged together by symbols. For example, all the data for IBM is in one chunk. then apple, and then some other symbol. Now you may be wondering, I just told you that this parted attribute can only be applied to integral values. So how can we actually apply it to a column with symbols in it? Well, it can be done if the symbols are enumerated. Now that's a different topic, but basically enumeration means that instead of using the symbols themselves, you're using a list of integral values to represent them. Anyways, in the background, when you apply the parted attribute, KDB is keeping track of the first appearance of each symbol or each value. This leads to a bit of an overhead. Again, this is like a hash table, leads to a bit of an overhead, but the benefits outweigh the costs for huge tables easily. In terms of using it on a simple list, here's how you can apply the parted attribute. So one, let's say we have 3 2's together, and then okay, see, here's the attribute you can use using backtick and p, and then on a list where all the similar values are placed together. Our final attribute is grouped. Grouped is a last resort type of attribute. I would not really recommend using it often because it has the most overhead. It is similar to parted attribute in the sense that it keeps track of location of data to speed up lookup, but unlike parted attribute, which only stores index of the first appearance, group stores indices of all the appearance. So what do I mean by that? Let's say you have a list 1 2 2 2 5 5 5 6 9 9 10 10 and then 5. All right, so we have this list. If we apply the function group on A, it returns all the indices where the unique values appear. So we can see 1 appears at the index 0, 2 appears at index 1, 2, and 3, and so on. 5 appears at index 4, 5, 6, and then later on the 12th index. So you get the point. Here, basically, when you apply the grouped attribute, KDB is keeping track of all the indices and where each value occurs, which is a lot of overhead. So I wouldn't recommend using it a lot. It can be used on any list. So we can take this list A and apply group on part grouped attribute on A. It could be applied on another list too, which is, you know, in a random order. It doesn't have to be like this. And there we go. One use case of grouped attribute is when you want to use it on real-time data to speed up lookup a bit. At the end of the day, when real-time data is persisted to a historical database, the data is rearranged and parted attribute is applied instead. If you're given a table or a list, how do you determine which attributes have been applied already? There's a function called attr, which can be used to see which attributes have been applied. So let's say our list A, if we apply group attribute to it, right, we can use attribute function on it, which will return the attribute that has been applied to it. Similarly, if you have a table, let's say we create a table T where we have let's try price as sorted 10, 20, 30, and then size, which is parted 100, 100, 200. So here's our table, and we have applied sorted attribute to the price column and parted attribute to the size column. If we wanted to see what attributes are applied to each column on a table, we can use the meta keyword, and we have discussed this keyword before and what each of these columns mean, but we didn't go into detail about this last column, which stands for attributes here. So you can see that the sorted attribute has been applied to price and parted attribute has been applied to size. This is all we have for today. I hope that was interesting. Finally, if you have any questions, reach out to us at himanshu@enlistq.com. Let us know if you have any feedback, any suggestions. Until then, have a great time. We'll see you later.